Okay. So we will see where this object will appear when we will see from here or here or here, when the observer will see. So for the image formation, what we will do, suppose first ray from the object is like this. And this is a normal incidence, so it will pass straight. Why I am saying this is a normal incidence? Here you can see bending of light. I have told you now, when there is a normal incidence,
Yes, sir.
Here the medium is changing, but then also there is no bending in the light. Why? Because this is the normal incidence.
Yes,
So,
sir.
that is why there is no bending here. Another ray from this object is supposed like this. Is like this. Now, as this ray is going from denser medium to the rarer medium, so for showing the refracted ray, we have to draw the normal. So this is the normal. This is the normal, and as this ray is going from denser to rarer medium, it will bend away from the normal like this.
Yes.
It will bend away from the normal like this. And when you will produce this ray in the backward direction, somewhere here you will get this. Means here the image of this object will be at this position. So where this object will appear, here this object will appear. Okay.
Yes,
Here.
sir.
And this object is appearing here due to the refraction of light.
Yes, sir.
Due to the refraction of the light, this object is appearing here. So this distance from the surface to this is known as the d dash, and this d dash is the apparent depth. Why I'm saying this is the apparent depth, when you will see the object, real position of the object is this, but the
Yes,
object
sir.
is appearing here.
Yes,
This is
sir.
the apparent position of the object. This is
Yes,
the
sir.
apparent position of
depth.
the apparent depth, and this is the observer here.
Yes, sir.
So D is the real depth, D dash is the apparent depth, and these are always measured from the surface. These are always measured from the surface. Remember this point. And what is N2 and N1? N2 and N1, remember, it is not
The refractive
necessary
index.
always. It is not necessary. There's always here will be air, here will be water. This is just an example. Here can be another pair of media like water and glass and all that. Okay.
Yes, sir.
So you have to remember N2 will be the refractive index of the medium from which
Yes.
light is coming. Okay. And N1
Yes,
is the
sir.
refractive index of the medium in which the light is going.
It is
So
going.
there is a relation between the refractive index and real depth and the apparent depth. That is refractive index N2 divided by N1 is equal to real depth divided by apparent depth. Real depth divided by apparent depth.
Apparent depth.
So this formula you have to remember, and apart from this formula, you have to remember two things. Number one, you will take the N2, the refractive index of the medium from where the light is coming, and N1 is the refractive index of the medium in which the light is going. Okay, one thing is this. Another thing you have to remember, all the distances you will measure from the surface. Okay, from the
Yes,
surface
sir.
you will take D also you will take from the surface, and D dash also you will take from the surface, or you can say interface between the two media. Okay, now we will drive this relation. So for driving this relation, suppose here is water and here is air, and it is not necessary that here is always water. Okay, so that is why I am removing now. Means here is medium having the refractive index n2, and here is another medium having the refractive index n1. And here is some object, and this object has the depth d below this surface, and O is the object and I will be represented by the image. So basically this is the object, and here is water. Here is water means here is another medium. Generally you will get water, but there can be another medium also. Here can be oil also. Oil, in the oil this object will be placed also. So not necessary that always here will be water. So this is the object. Okay, so we know that how to form the image of this object. So first ray from this object is suppose like this. It will pass straight, no deviation. Why? Because this is the normal incidence. Now another ray from this object will be suppose like this. Now we will draw the normal for showing the path of the refracted ray. So this is the normal. Okay, then this will bend away from the normal, and we will produce the refracted ray in the backward direction like this. So somewhere here the image will form. This is the refracted ray. Okay, and you can say this is the angle of incidence. This is the angle of incidence because this is normal for this ray. Okay, for this ray, this will be the angle of incidence because okay.
Yes, sir.
This is I, and this is the angle of refraction R. Now we will use geometry. Now as this line is same line, this line is the same line, as you have produced this ray in the backward direction. Okay. This ray is actual path of the ray is, this ray is going in this direction, but you have produced this ray in backward direction, and here you are getting the image of the object. Here you are getting the image of the object. Okay.
Yes, sir.
I is the image of the object. Now this angle will also be R. This angle will also be R. Why? Because this is the same line, and this line and this line, this ray and this normal are parallel. So this angle is equal to this angle. Now see, this normal and this ray is parallel. So this angle is I. So this angle will also be I.
Yes.
And suppose this distance is X. Suppose. And suppose this is point O, and this is I, and this point is suppose A, and this point is suppose B. So B. Okay. Now see in triangle OAB. See in triangle OAB.
OAB.
So this angle will be right 90 degree. This angle will be 90
Yes,
degree.
sir.
Okay. So in triangle OAB, we can find tan of I. We can find tan I. So tan I will be perpendicular, means x divided by this distance. Tan I can be find it out. Perpendicular means AB. AB divided by OA.
Yes, sir.
AB divided by OA.
OA.
So AB is x, and OA is this D. So tan I is x by D. Now see in triangle AIB. In triangle AIB, find tan of R. Tan of R. So tan of R can be given by x divided by AI.
Yes, sir.
Or you can say AB divided by AI. AB is X and AI is this distance, means this apparent depth, D dash. D dash is the apparent depth. So we have
Yes, sir.
10I, we have 10R. Now at this interface, apply the Snell's law. So Snell's law, how we apply the Snell's law? Refractive index of this medium multiplied by sin I, that is refractive index of this medium is N2 multiplied by sin of I is equal to refractive index of another medium, that is N2 multiplied by sin R.
Yes, sir.
Sorry, N1 multiplied by sin R. Here is N1, na? Refractive index of another medium is N1. So that is why I have written that. Now from here, suppose this is equation number 1. Here is one assumption. Here is one assumption that rays from object are paraxial. Paraxial means these rays are very close, very close. So if these rays are very close, so this angle I and this angle R are very small. So you can say that angle I and angle R are very small. If these angles are very small angles, then tan I, not tan I, sin I can be approximately written as I, and this I can be written as tan I. Okay. In the same way,
Yes, sir.
sin R can be approximately written as R, and this R can be approximately written as tan of R. So in this equation, you can, instead of sin I, instead of this sin I, you can put tan I, and instead of sin R, you can put tan R. So here you can write N2 into, instead of sin I, you can put tan I, and N1 into tan R. Now N2 into, what is tan I? Tan I x by d.
Yes, sir.
Okay, so it is x by d. So it is N1. What is tan R? Tan R is x by d dash. X by d dash. So this x and x will cancel out. You will have N2 by N1 is equal to d by d dash. And what is d? D is the real depth, and
Yeah.
d dash is the apparent depth. Real depth divided by the apparent depth.
Yes, sir.
So in this way we can do the derivation. I have just applied here some concept of geometry, and Snell's law we have applied, and some concept of trigonometry. Okay, and we can do the derivation. Here angle I and angle R are very small, because we assumed that rays are paraxial.
Yes, sir.
Paraxial means these rays are very close. So this angle I will be very small. Accordingly, this angle R will be very small. Okay, so first you can write down this very important concept. We will solve the question also on this after this. So
Yes, sir.
learn at least this relation, N2 by N1 is equal to real depth divided by apparent depth, but you should know what is N2 and what is N1. Okay.
Yes, sir.
Right. Have you got it, Harsh?
Yes, sir.
Things
Yes.
how to do.
Hold on. Done, sir. Second scroll down.
This is the final result. So you have to remember n2 by n1 is equal to real depth divided by the apparent depth, and n2 is the refractive index of the medium from which the light is coming, and n1
Yes,
is the
sir.
refractive index of the medium in which the light is going.
Going. Done, sir.
Okay, so we will now solve numerical on this. So this is the question. So here is water. Hmm. This is water, and there is one fish under this water, and this fish is at a depth of 24 centimeter from the surface. This is the interface, you can say.
Yes, sir.
From this interface, okay, and this is water. So this fish has a distance of 24 centimeter. Now from this interface, and here is air. So there is a bird here. This is a bird. This is a bird. This is a bird, and this bird is at a height of 36 centimeter. And water have the refractive index 4 by 3, and air has the refractive index of 1. This is the condition given, and they are asking find depth of the fish. Depth of the fish seen by the bird. First question. Second, they are asking find the height of the bird seen by the fish. First, they are asking depth of the fish. Depth of the fish seen by the bird. So first, we will solve the first part. Okay. So first part, what you will do here means depth of the fish seen by bird. So who is the observer? Bird is the observer, na? In first case. Bird is the observer. So light will come towards the observer, means from medium, this medium, the light will go to the bird. Is it or not? Hello? Harish?
Yes, sir. Can you hear me?
Yeah, I can hear you. Can you hear me?
Yes, sir.
I am saying this bird is the observer in first case. So, so light will go from this medium to this medium.
Yes, sir.
Okay. Because observer is in this medium. Because the observer is in this medium, and this bird is observing this fish. As this bird is observing this fish, means light is coming from this medium to this medium. Light from the fish is coming to the bird. That is why the bird is able to see the fish.
Yes, sir.
So N2 is the medium. What we have taken the N2. N2 is the refractive index of the medium from which the light is coming. So N2 will be the refractive index of the water, that is 4 by 3.
Yes,
And
sir.
what is N1? N1 is the refractive index of the medium in which the light is going. So light is going in air. So what is the refractive index N1? That is 1.
1.
Now we want to find the apparent depth of the fish, because this bird will see the fish and here is the water. So there will be some refraction, and due to that refraction, this fish will not appear at its original position. It will
Yes,
appear
sir.
at somewhere else position. So we will apply this formula N2 by N1. N2 by N1 is equal to real depth divided by the apparent depth. Divided by the apparent depth. So N2 by N1, real depth we represent with D, and apparent depth we represent with D dash. So real depth of this fish is given. 24 centimeter is the real depth. So
Yes.
D is given. D is given as 24 centimeter. Now N2 is given as 4 by 3 and N1 is 1. So N1 is 1. Real depth is 24. Apparent depth d dash we want to find. So can we find d dash? So 4 6 is 24 and 6 3 is 18.
Yes, sir.
So d dash will come out to be 18 centimeter. So the apparent depth of the fish will be 18 centimeter. So somewhere here will be the fish. According to this word, this will be the apparent position of the fish. So fish is appearing here, but in actual the fish is here. So for this bird,
Yes, sir.
what is the depth seen by the bird? What is the depth? So this bird is here and fish is here. So what is the depth seen by the bird? 36 plus 18.
Yes, sir.
This 10 plus this is 10. So you can write depth of fish seen by bird is equal to bird is 36 centimeter above the surface
Yes,
and
sir.
fish is appearing 18 centimeter below the surface. So 36 plus 18. 36 plus 18. So we
18.
will get 54 centimeter. 54 centimeter we will get.
Yes, sir.
Now in the next question, they are asking find the height of the bird. They are asking find the height of the bird seen by the fish. Now this time the fish is seeing the bird.
Yes, sir.
So if this fish is seeing the bird, so from where the light will come? From
From
the
36
bird?
centimeter.
No. Huh.
No, from new one. Yeah, from up. From air.
From the bird, the light. Suppose, for example, here is some bulb, and here is
Yes.
okay. Take one example. Suppose here is my mouth. So I am just watching my mouth. So how is it possible that I am able to see the mouse? Because light is coming from the mouse to my eyes. That is why I am able to see the mouse. In the
Yes,
same
sir.
way, this fish is seeing the bird. So if this fish is able to seeing the bird, it means that from the bird the light is coming to the eye of the fish. Means this time you can say the light is coming from air to the water.
Yes, sir.
Now accordingly we will take N2 and N1. Now can you tell me what is the N2 this time?
N2.
N2.
Sir, N2 is this, right?
No. Just listen. N2 is the refractive index of the medium from
Yeah.
which the light is coming. So
Yes.
from
From
which
which the
medium
light
the
is, so
light?
it is air one.
Yeah, very good. N2 is 1. So in answer number second, N2 this time is 1 and N1 this time is 4 by 3. Now you are finding the real and apparent depth for the bird. Now we are finding the real and the apparent depth for the bird. Why? Because this fish is seeing the bird and this
Yes,
bird
sir.
is actually here. But due to
Yes.
the refraction, this will be not the position
Of the
appeared
bird.
by the fish. Huh.
Yes.
And that is given by the same formula uh, N2 by N1 is equal to real depth divided by the apparent depth. So what is N2? N2 this time is 1
Yes,
and
sir.
N1 this time is 4 by 3. And what is the real height of the bird? 36 centimeter. 36. So you will put here 36. So in this case, D is equal to 36 centimeter. D is equal to 36 centimeter. So you can put here 36 and here you will get D dash. So now you can find the D dash. It will become 3 by 4 is equal to 36 into D dash. So this will be cancel out. 3 ones are 3, 3 twos are 6, So D dash will be 48
Yes,
centimeter.
sir.
D dash will be 48
48
centimeter.
centimeter.
So what is the apparent height of the bird? 48 centimeter. So we can say that this bird will appear to the fish somewhere here. Okay, somewhere here, and at a height of 48 centimeter from the surface. And what is this? This is the apparent position of bird. Okay, apparent
Yes, sir.
position of bird, and this is the apparent position of fish. Okay, so now can you tell me what is the height? Can you tell me what is the height uh, of the bird seen by the fish?
Height of the bird seen by the fish.
Hmm. Just
Uh,
think for 1 minute, then tell me. First thing means what can be the height? See, we
so
have
it will be
because
98 plus 18, right?
hmm,
The height will be like
hmm,
height of the bird seen by the fish will be 98 plus 18, right?
hmm. Actually, this is not 98. This is 48.
Yeah, sorry, 48 plus 18. Sorry.
No. 48 plus 80. No. Actually, this is little bit here confusion here. Actually, because the fish is here.
Yeah.
Think in terms of the fish. This fish is here, and this fish is watching the bird here. But for this fish, the bird is here at a height of 48 centimeter. But
Yes.
where is the fish is at a distance of 24 centimeter.
29 centimeter.
It will be 24 plus 48.
Yeah.
24 plus
Plus
48.
48. Yeah.
Yeah. So you can say height of bird seen by fish is equal to this height 24 plus 48. 24 plus 48,
48.
that that will be become 72 centimeter. Okay, so please write down.
Yes, sir. Second scroll down. Sir, more, sir, more. Done, sir, done. That's it. That's it. Sir, to the first part, sir. Okay,
This
thank you,
one
sir.
completed? This one
No, sir, I
completed?
have to
Okay.
do just last line,
Okay,
last
okay.
line.
Okay, okay.
Second scroll down. Done, sir.
Done. Okay.
Sir, I had a question, sir.
Okay.
Sir, that day, like, I gave the mock test, sir. Sir, when will I get the marks?
Okay. So on after Friday, I will check that. Okay. Means
Okay.
on
Okay,
the
sir. No problem. No problem.
Saturday, I will declare the marks. Okay. Actually, I have not checked the all the papers yet because of the classes, na. So
Yes, sir.
on Friday, I think I will check that and I will display the marks. Okay. Fine.
Yes, sir. Yes, sir. Yes. Sir, just
Okay.
a
So
second. My
now
phone
we will
is
see, na.
unstable. I can't hear you properly.
Okay. Okay. Now it's fine.
Just a minute, sir. Just a minute. No, I think it's fine.
Okay. So we will see shift through the glass slab. Shift through the glass slab. Have you seen a glass slab in your lab? I think
Yes, sir.
you have glass slab. So
Yes,
glass
sir.
slab is
Yes,
like
we have
this.
done that.
Uh,
Yes.
glass slab. So suppose this is a glass slab, and this glass slab have the refractive index mu, and this glass slab has the thickness T. And one more thing. Okay. Here is the observer. Here is one object. Okay. Here is one
Yes, sir.
object. On the left side of the glass slab is the object. On the right side of the glass slab, the
Is the
observer is there.
observer.
So this is the object. And here is the observer. Here is the observer. Okay, so this observer is observing this object, means the light is coming from the object to the observer. This is the thing when you are just watching something, and from that something the light is coming to you. That is why you are able to see that something.
Yes, sir.
So we will see if this person, for example, if there is no glass slab, then this object will appear from the object at this distance.
Yes, sir.
Okay. Now what happened? We have placed one glass slab in between. Now we will see where this object will appear to this person. Okay. So for that we have to draw the ray diagram. So this is the object, and from this object, what we will do, we will see how the refraction will take place, and then the amount of refraction will decide the where this object will appear to this observer. Okay, so suppose, for example, suppose one ray from the object is like this. Okay, from the object is like this is the first ray from the object, and as here is air, here is also air, means around the glass slab, this is a glass slab, around the glass slab of refractive index mu, uh, air is there. So
Yes, sir.
this light ray means this object is present in air. So light is going from air to the glass slab first. Okay, light is going from the air to the glass slab first, and this is the normal. What is this? This is normal.
Normal.
So now what will happen? As the light ray is moving from rarer medium to the denser medium, it will bend towards the normal, like this.
Yes, sir.
It will bend towards the normal like this.
Bend
Okay.
towards the normal. Yes.
Towards the normal. Now after this light ray is move. This light ray will move from this glass slab to the air. Okay. So now this light ray is moving from this glass slab to the air. So now glass is the denser medium and air is the rarer medium. So this ray is moving now denser to the rarer medium. It will bend away from the normal. So it will bend away from the normal now. Like this, you can see here. Bend away from the normal. Okay. So this is the final ray of the light from the object after passing through the glass slab. And when you will produce this ray in the backward direction, somewhere here this object will appear to you. Here is the object appear to you. Appear to you means appear to this observer.
Yes, sir.
So why this is happening? Due to the refraction through the glass slab. So when you will produce this ray in the backward direction, this image will form here. This is the image. Now object is present here. and to this observer, this object is appearing here.
Yes, sir.
So this distance, now, this distance is known as the shift.
Yes.
Shift. S-H-I-F-T, shift. Shift is represented by S. And what is mu? Mu is the refractive index of the glass of slab. Refractive index of slab. Now around both the side of the glass slab, there is air, and there can be any other medium also around the glass slab. There can be water also. So in that case also there will be some shift. And okay, so remember few points regarding the glass slab, and one more to tell you here. The shift through the glass slab, this shift S through the glass slab will be given by thickness of the glass slab multiplied
Yes,
by
sir.
1 minus 1 upon refractive index of the glass.
Glass slab.
So this formula we will use to solve the numericals. But this formula is valid when both side of the glass slab is air. Both side of the glass slab is air. Okay, then this formula is valid. Now there are some few points I have written. If medium on both side of the glass slab is same but not air, then in
Yes, sir.
that case the shift through the glass slab will be given by thickness of the glass slab 1 minus refractive index of the surrounding divided by the refractive index of the slab.
Yes.
Okay. Few more points. Rays are paraxial. What is the meaning that rays are paraxial? Means if there is one more ray from this object like this. Many times we have this one ray from this object is like this, suppose like this. So these incident rays are very close.
Yes.
Okay, these incident rays are very close. Okay. So these are known. This is known as the paraxial rays. Paraxial rays means very close rays. Medium on both side of the slab is same, and if surrounding medium is not air, then shift through the glass slab is given by 1 minus mu of surrounding divided by the mu of slab. Third point, distance of the object from the slab does not matter for the shift, because you can see here shift is not depending upon the distance where you are placing the object from the slab. You can see in the formula. And this is the important point here. The important point is if shift is positive, if shift is come out to be positive,
Positive.
then
Yeah.
shift is in the direction of the
Direction
incident
of
ray.
incident ray.
If
Shift
shift
is
is come
negative,
out
then
to be
direction is in
negative,
the
then
incident. Opposite direction wise.
when we will solve the numerical, you will understand this point more clearly.
Yes, sir.
So just draw the ray diagram. And remember, T is the thickness of the glass slab. T is the thickness. Thickness of glass slab, or you can say thickness of slab.
Second scroll down. Done, sir.
Remember this formula and this formula, this formula. Okay, this is when both side of the glass slab air, then shift is given by thickness of the glass slab
Yes, sir.
multiplied by 1 minus 1 by refractive index of the slab.
Glass slab.
If on both the side there is some another different medium, so you can say in that case the shift is given by thickness multiplied by 1 minus refractive index of the surrounding medium divided by the refractive index of the slab. So we will solve questions on the same concept. First question. So in this question, they are saying that there is a glass slab. You can see here, and around the glass slab there is air. Here is also air. Here is also air, and this is the object place, and here is the observer. Observer. And this observer is looking through the glass slab this object. Okay, this is the object here. We can just increase the size. This is the object. Okay, and they are asking find the shift. Find the shift, they are asking.
Shift, yes.
Now here both side on the glass slab there is air, so the formula for the shift is given by thickness of the glass slab multiplied by 1 minus 1 upon refractive index of the glass slab.
Yes.
So thickness of the glass slab is 15 centimeter.
Yes.
So thickness
So
is
15 minus 1 by 1 by 1.5.
15 1 minus 1 by
1 by
1.55.
1.55.
1.5. So you will get 15, and here you will get 1.5 minus
1.5
1
minus 1.
divided by 1.5, and
Yes, it will be
1.5 when we
0.5.
will cancel, it will be cancel out 10 and it will be 0.5, it will
Yeah.
become plus 5 centimeter.
Yes.
So shift is positive now.
Yes, sir, it is positive.
So if shift is positive, then shift is in the direction of incident ray.
Incident ray.
Shift is in direction of incident ray. Incident ray or incident ray. So object is here. So incident ray will be in this direction.
Yes, sir.
So the shift will be in this direction like this. The object will appear here somewhere, and this distance will be 5 centimeter. So have you understood the concept of positive shift or the negative shift? Means this the object will appear here to this observer because the shift is in the direction of the incident ray.
Yes, sir.
Another question. Just little difference between both the questions. Little difference. Now same question is there, glass slab is there, and this glass slab have the same thickness of 15 centimeter, refractive index this, and this object is placed at a distance of 10 centimeter.
Yes, sir.
Now they are asking the shift, but this time uh, around the glass slab, the medium having the refractive index of 2. So shift through the glass slab is equal to the thickness of the glass slab 1
Yes.
minus refractive index of the surrounding divided by the refractive index of
Refractive
the
index
slab,
slab.
glass slab. Okay. So we will find out the shift. Shift is equal to, what is the thickness? Thickness is 15 centimeter.
15
1 minus
minus 1 minus 2 by
refractive index of the slab. Sorry, refractive index of the surrounding. Okay.
2.
So refractive index of the surrounding is given as 2. Okay, yes. So we will write 2 divided
2
by
by
1.5.
1.5. Yeah.
So it
So it will
will
be
be
1.15 into
it will be
1.5 minus 2 by
1.5.
1.5. So it will be 0.1, 0.5 minus 0.5.
Minus 0.5. So it is 15 multiplied by minus
Minus
of
0.5.
0.5. 15 multiplied by minus of 0.5 and divided by 1.5. So when you will cancel this, this will become
It will
10.
be 10.
So shift will be minus 5 centimeter. So in this case, you are getting shift is negative, means shift is in the direction of, or in the opposite direction of the incident ray.
Yes, sir.
Because this is negative. Shift is in
Opposite direction of incident.
opposite direction of incident ray. So now direction of incident ray will be in this direction.
Yes, sir.
Okay. Means this object will appear in the here somewhere here.
Yes, sir.
So this will be the shift of 5 centimeter. Now this time the shift is in the opposite direction of the incident ray. Means this object will appear far in this case, and here in this case this object is appearing near as compared to the actual position. Okay. So write down question and answer. Have you understood now why this?
Yes, sir.
Why
Yes, sir.
here the shift is in that in the direction of the incident ray is here, and in that in the earlier in the next question the shift in the opposite direction of the incident ray, because there the shift we are getting negative shift. That is why
Yes.
the shift is in the opposite direction of the incident ray. And accordingly we have shown the image. Have you heard about the total internal reflection?
Yes.
Total
Yes, sir.
internal
Yes.
reflection. This time now from your syllabus, total internal reflection is there,
Yeah,
but
but
the
it is related, right?
application,
Some part is related.
yeah, somewhat means the application of total internal reflection like optical fiber, mirage, and all these. That application part of the total internal reflection is deleted.
Yes, sir.
So we will only discuss the critical angle and the total internal reflection.
Done, sir.
Completed? Okay. So see the difference in both the question. In this
Yes, sir.
question, around the glass slab, there is air. And in this question, around the glass slab, there is no air. There is any other medium having the refractive index of 2.
Done, sir.
Now we will discuss the critical angle and total internal reflection. Critical angle and total internal reflection. Suppose this is the here is the dense. This is the interface. Okay, this is the interface. And uh, this interface is separating the rarer medium to denser medium. So suppose, for example, first ray is like this. First ray is going from denser to rarer medium like this at an angle of incidence I1 and angle of refraction is R1.
Ah,
Okay. After that, what you have done? After that, you have increased the angle of incidence I2 and the okay, and the accordingly there will be the angle of refraction. Angle of refraction will also increase.
yes, sir.
Angle of refraction will also increase. Okay. So this is the incident ray. Incident ray means the ray is going from denser to the rarer, and this is the normal. After that, you have increased the angle of incidence, and the angle of refraction will. Now you can see whenever the light ray is going from denser medium to the rarer
Yes,
medium,
sir.
it will bend away from the normal. So you can see the light ray is bending away from the normal. And further you have increased the angle of incidence, further the light ray will bend more away from the normal. Now you can see this R2 angle will be greater than R1. Okay. Now what you have done for this is I2. For example, suppose this I1, just an example I am saying, suppose this I1 is the 30 degree. Suppose this I2 you have taken as 35 degree. Means you are increasing the angle of incidence.
Yes, sir.
Now you have increased the angle of incidence, suppose 42 degree. And for this angle of incidence, what happens? This is the incident ray, and the value of this angle of incidence is 42 degree. And suppose
Yes, sir.
for this angle of incidence, the light ray is going like this, means grazing the surface like this. Like this. So now, in this case, what will happen? What will be the angle of refraction? This will be the angle of refraction. This is the
Yes, sir.
refracted ray, na? This is the refracted ray. So this is the refracted ray. This refracted ray is suffering the grazing. Okay, grazing means this ray is moving along the surface. So angle of refraction here becomes 90 degree. And this angle of incidence is known as the critical angle. I is equal to C. And what is C? C is the critical angle.
Yes, sir.
So what do you mean by the critical angle? Critical angle is the angle of incidence when light ray is going from denser to rarer medium, for which the angle of refraction becomes 90 degree. The angle of refraction becomes 90 degree, or you can say when the refracted ray is moving along the interface or grazing. Now this angle 42 degree here is this is just an example. I am not saying this will be exactly 42. This is for your understanding. I have taken
Yes, sir.
for your understanding. So C is the critical angle. So this angle, what is the critical angle? If someone is asking, the angle of incidence for which the angle of refraction becomes 90 degree and light ray is moving from denser to rarer medium.
Rare medium.
Critical angle. Now further you have increased the angle of incidence. Suppose here in this case, the angle of incidence, this is the angle of incidence I, and this I is, you have increased to 43 degree. Okay, suppose you have increased the angle of incidence, and that angle of incidence, suppose you have increased to 43 degree. So if the angle of incidence becomes greater than the critical angle, and what was the critical angle? 42 degree for the same interface,
Yes, sir.
for this medium. Now angle of incidence this time becomes 43 degree. If the angle of incidence becomes greater than the critical angle, then there will be no refraction. There will be only reflection. There will be only reflection. So the
Reflection.
light ray will be reflected, not refracted. It will be reflected.
Reflected.
So, and this is totally reflected, and that is why this is known as the total internal reflection. What is this? What is happening here?
Total
Total internal
reflection.
reflection. Okay.
Yes, sir.
So if this is the condition of reflection, so angle I and angle R both will be equal. Okay, no doubt. So on increasing the angle of incidence, but the condition is light should go from denser to rarer medium. Okay, so you can see some of the conditions. So these are the conditions for TIR. TIR means total
Yeah.
internal
Light
reflection.
should move from
Light,
denser to
light
rare.
will
Angle of incidence should be
and
greater than a critical angle.
uh, can now note down.
Because hold on.